Good day, viewers. Welcome to this class. And today we'll be looking at NABTEB Physics past questions. And these questions are both objective questions and theory questions. Let's dive right into it. First question here says, a body is projected vertically upward with a speed of 40 meters per second. So we are given the initial velocity of this body as 40 meters per second. Then neglecting air resistance, calculate the total time it takes to return to the ground. So what they're asking us to find here is the time of flight. We do not know. And they give us G as 10 meters per second squared. So we know that our time taken is equal to 2 time of flight. So our time of flight is equal to 2 time taken, sorry. Our time of flight, T, is equal to what? 2 time taken. So twice the time taken for the ball to get to maximum height is our time of flight. So it means that we know that our time taken is supposed to give us U over G. So this is the same thing as saying that my time taken is 40 divided by 10, which means that my time taken here will give me what? 4 seconds. It means that my time of flight is equal to what? 2t, meaning that my time of flight, which is the time it takes for it to get to the ground, is 2 times 4, which will give me 8 seconds. So the correct answer to this question is option D, which is 8 seconds. Moving on to question number 2, it says a car of mass 1,200 kilograms. So we have the mass of the car as 1,200 kilograms, moving at 25 meters per second. So the velocity of the car was given as 25 meters per second. Said calculate the kinetic energy loss. So we are looking for the KE lost. KE lost. We do not know, but we know that our KE or KE lost is equal to half mv squared. So this is the same thing as saying that I have 1 over 2 times 1,200 times 25 squared. So this will give me 600 times 625, because 25 squared will give me 625. This is times 600, and that will give me 375,000 joules, which is the same thing as saying I have 3.75 times 10 raised to power 5 joules. So our correct answer is 3.75 times 10 raised to power 5 joules. Moving on to question number 3. Question number 3 says a force of 200 newton. So we have a force of 200 newton. A force of 200 newton. So our force here was given as 200 newton. Pulls a load at an angle of 30 degrees. So our angle here is 30 degrees to the horizontal. If the displacement is 5 meters. So our displacement S is 5 meters along the horizontal. Calculate the work done. Now the work done when you pull an object on the horizontal surface at an angle is equal to Fs cos theta. So this is the same thing as saying that my work done is 200 times the distance or displacement is 5 times cos 30. So this will give me, that will give me 200 times 5 times 0.8660. So that will give me 866.02 joules, which is approximately equal to 866 joules. So the correct answer to this question is option C, which is 866 joules. Moving on to the next question. The question says a machine. A machine. So this question number 4, it says a machine of velocity ratio 5. So our velocity ratio is 5, is used to lift a load of 100 newton. So our load is 1,000 newton through a height of 2 meters. So our height is 2 meters. If the efficiency of the machine is 80%, our efficiency was given as 80%. Calculate the effort applied. Calculate the effort applied. We do not know. But we know that our efficiency is equal to mechanical advantage over velocity ratio. So this is the same as saying that my efficiency is equal to my mechanical advantage is load over effort divided by velocity ratio. So this is the same thing as saying that I have my load by looking for the effort applied. So this is the same thing as saying that my efficiency, which is 80%, so I have 80 over 100 is equal to my load is 1000 over my effort there is unknown. This is divided by velocity ratio in the question was given as 5. So I have 8 over 10 to be equal to 1000 over E times 1 over 5. 5 here 1, 5 here 200. So I have 8 over 10 is equals to 200 divided by E. This means that my effort is equals to 200 times 10 divided by 8. So that will give me my effort to be 250 Newton. So our effort is 250 Newton, and that is not part of the options here. So I guess the options here are typographical errors, as the option is not there. From there, that takes us to question number 5, which is a 2 kg block. So the mass of the block was given as 2 kg. Slide down a rough incline of angle 30 degrees. So our angle was given as 30 degrees. And the length was given as 5 meters. So if the coefficient of friction is 0.2, so our mu was given as 0.2, calculate the acceleration of the block. So if we are to find the acceleration of the block, we know that mass times acceleration of the block is going to give me the mass times the acceleration to gravity sine theta minus the frictional force, which is mu mg cos theta. So this is the same thing as saying that I have mass times acceleration to be equals to mg in bracket sine theta minus mu cos theta. So our m will cancel m, so it means that my a is equals to g open bracket sine theta minus mu cos theta. So this means that for me to find my acceleration, since I already know what my theta is, I know what mu is, and I know that g is a constant g. Since g was not given, we're going to use 9.8 meter per second square. So this means that my acceleration is equals to 9.8 in bracket sine 30 minus 0.2 times cos 30. So this will give me 9.8 in bracket sine 30, that's 0.5 minus 0.2 times 0.8660. So I have 0.2 times 0.8660. So that will give me 9.8 in bracket 0.5 minus 0.1732. 0.5. So that will give me 9.8 in bracket 3268. So if I multiply this, that will give me 3.2 meter per second square. It means that the acceleration of this body is 3.2 meter per second square. Moving on from there, question number 6. It says the frequency of a note emitted by a car is observed to change from 500 Hz to 450 Hz. So we have the frequency forward. Let's say this is frequency forward to be 500 Hz. And then we have the frequency away. Let's just name this as frequency away to be 450 Hz. Then, as the car passes an observer if the speed of sound in air is, so we have given the velocity of sound to be 340 meter per second. Calculate the speed of the car. So we are looking for the velocity of the car. We do not know. So for us to solve this question, we have to bring the Doppler effect formula, because this question is talking about what? The relative motion between a moving car and an observer, and that is what? Doppler effect, which means that we are going to be having the frequency forward over the frequency away to be equals to V plus U over V minus U. So this is the same thing as saying that I have 500 over 450 to be equals to V plus U over V minus U. So this is the same thing as saying that I have, this will cancel this, 5 here 10, 5 here 9. So I'll have 10 over 9 to be equals to V plus U over V minus U. If I cross multiply here, I'll be having 10 open bracket V minus U is equals to 9 open bracket V plus U. So if I open the brackets, I'm going to have 10V minus 10U to be equals to 9V plus 9U. If I collect like terms, what I'll be having is 10V minus 9V is equals to 9U plus 10U. So this will give me V to be equals to 19U. So remember in the question they gave us the what? The velocity of sound in air. So if we impute that, it means I have what? 340 is equals to 19U. Divide both sides by 19 divided by 19. So I have 340 divided by 19. So that will give me the velocity of the car to be 17.89 meter per second. So it means that the velocity of this car is 17.89 or 0.9 meter per second. Moving on to the next question, which is question number 7. It says, a string of length 1.2 meters. A string of length 1.2 meters. So we have a string of length 1.2 meters. Our length was given as 1.2. Is fixed at both ends. The fundamental frequency produced, our F0, was 150 Hz. Calculate the speed of the wave along the string. So we are looking for the velocity of the wave. We do not know. But we know that for a string that is tied at both ends, that our fundamental frequency is equals to V over 2L. Our F0 is equal to V over 2L for a string that is tied at both ends. So because this is what I have, this is the same as saying that if this is over 1, this means that my velocity is equals to 2L F0. So it means that the velocity of this string is going to give me 2 times 1.2 times 150 Hz. So I'll have 2 times 1.2 times 150 Hz, and that will give me 360 meter per second. It means that the speed of the wave along this string is going to be what? 360 meter per second. Moving on from there to question number 8. It says, the critical angle of a certain glass material is 42 degrees. Calculate its refractive index. Calculate its refractive index. So in this question, we have to find the refractive index of this certain glass. But they gave us the angle, the critical angle, see, to be what? 42 degrees. And we know that from our formulas of refractive index, that the refractive index as relating to critical angle is equal to what? 1 over the sine of the critical angle. So this means that the refractive index of this certain glass, therefore, will be equal to 1 over sine 42 degrees. So this is the same thing as saying that I have 1 over sine 42 will give me 0.6691. So 1 divided by this will give me 1.49. So it means that the refractive index of this certain glass is going to be what? 1.49. Moving on from there, that takes us to question number 9, which says a concave lens forms a real image 20 centimeters from the lens. So the image distance was given as 20 centimeters. Then it said when the object is placed 30 centimeters away, so the object distance was given as 30 centimeters. They say calculate the focal length of the lens. So the focal length is unknown. So all we have to do here is introduce our lens formula, which says that 1 over focal length is equals to 1 over image distance plus 1 over object distance. So this is the same as saying that my 1 over focal length is equal to 1 over 20 centimeters plus 1 over 30 centimeters. So that will give me 1 over focal length to be equals to the LCM of this here will give me 60. So looking at this, 60 divided by this will give me 3 times this I will have 3. Then 60 divided by this will give me 20. Will give me 2 times this I will have plus 2. So I will have 1 over focal length to be equal to 5 over 60. So if I cross multiply, it means my focal length, 5 focal length is equals to 60. Divide both side by 5 divided by 5. So I have 60 divided by 5. So it means that my focal length is equals to 12 centimeters. So it means that the focal length of this convex lens is going to be what? 12 centimeters. Moving on to question number 10, it says a diffraction grating has 500 lines. So the number of lines was given as 5,000 lines per centimeters. So they said find the angle of deviation. So we are looking for theta, we do not know. For the second order, so my m was given as 2. Spectrum of light of wavelength. So we have our lambda as 6.0 times 10 raised to the power minus 7 meters. So we are asked to find the angle of deviation. But we know from our formula that my d sine theta is equals to m lambda. So we don't know what d is. My d here, d is equals to 1 centimeter over n, as we are given our n to be 5,000 lines per centimeters. So in order for us to find our deviation, we have to what? Convert the centimeters here to meters and then divide it by the what? The number of lines. So it means that my deviation here is going to give me 0.01 meter divided by 5,000. So that will give me 2 times 10 raised to the power minus 6 meters. So now that I've gotten my deviation, I will use that to find out what my angle of deviation is. So if I just impute this into our formula, my d is 2 times 10 raised to the power minus 6 times sine theta is equal to m is 2 times lambda is 6 times 10 raised to the power minus 7. So this would mean that I have sine theta to be equals to 12 times 10 raised to the power minus 7 divided by 2 times 10 raised to the power minus 6. So this means that I have sine theta to be equals to 12 over 2 times 10 raised to the power minus 7 minus 6. So that will give me 6 times 10 raised to the power minus 7 plus 6, which will give me 6 times 10 raised to the power minus 1. And that would mean that my sine theta is equals to 0.6. So It means my theta here is going to be sine inverse or arc sine of 0.6. So sine inverse of 0.6. It means that my theta is going to be 36.9 degrees. It means that the angle of deviation for the second order spectrum of light of this wavelength is what? 36.9 degrees. Moving on to question number 11. It says a copper calorimeter of mass. So we have a copper calorimeter. We have a copper calorimeter with a mass. So a copper calorimeter of mass 0.1 kg. So the mass of this copper calorimeter is 0.1 kilogram. Contains, so let's say this is mass of calorimeter, contains 0.25 kilogram of water. So the mass of water was given as 0.25 kilogram at 20 degrees Celsius. It means that the temperature of the water is 20 degrees Celsius. A metal of mass, so we have the mass of metal to be 0.2 kilogram at 100 degrees Celsius. Temperature of metal to be 100 degrees Celsius is dropped into the calorimeter if the final temperature is 25 degrees Celsius. Final temperature, theta final, is 25 degrees Celsius. Calculate the specific heat capacity of the metal. So the specific capacity of metal is unknown. Then it said, take the specific capacity of copper. Specific capacity of the calorimeter is 400 joules per kilogram per Kelvin. Then it said, the specific capacity of water, take the specific capacity of water to be 4,200 joules per kilogram per Kelvin. So, in this question, we have to find the specific capacity of the metal. Now, looking at the parameters, you know that this question is based on the law of calorimetry, which says that what the heat lost by a substance must be equal to the heat gained by another substance. So, in this question, you realize that what the water initially was inside the calorimeter, which means that both the water and the calorimeter will be gaining heat because they have a lesser temperature compared to the temperature of the metal. And because the both of them are together, it means that the temperature of the water, which was 20 degrees Celsius, is also equivalent to the temperature of the calorimeter. So, in order for us to solve this question, we simply tell them that from the law of calorimetry, that the heat lost must be equal to the heat gained. Which means that the heat lost by the metal must be equal to the heat lost by the calorimeter plus the water. So this means that what I have here is MC change in theta for the metal is equal to MC change in theta plus MC change in theta. But the formula here is not going to be the same because the mass of the metal here is mm times the specific capacity of the metal here is Cm times the change in temperature of the metal. Because the metal has a higher temperature than the final temperature, it means that what I'll be having here is theta of the metal minus the final temperature. So this will be equal to the mass of the calorimeter times the specific capacity of the calorimeter times, but on this part, on the heat gain side, you discover that what? The final temperature is higher than their initial temperature. So I'll be having theta final minus temperature of the water. This is plus mass of water times specific capacity of water times theta final minus temperature of the water. So it means therefore that what I'll be having here from the parameters that we are given, the mass of the metal was given as 0.2 times the specific capacity of the metal is unknown, so I have Cm times the temperature of the metal was 100 minus 25, which is the final temperature. This is equals to the mass of the calorimeter is 0.1 times the specific capacity is 400 times the final temperature here is 25 and the temperature of the water is 20. This is plus the mass of the water is 0.25 times the specific capacity of the water is 4,200 times the change in temperature here is 25 minus 20. So this means that I have 0.2 times cm times 75 is equal to 0.1 times 400 will give me 40 times 25 minus 20 here will give me 5 plus. Then I have 0.25 times 4,200. That will give me 1,050 times 5. So this means I have 0.2 times 75, which will give me 15 cm is equals to 40 times 5 will give me 200 plus 1050 times 5 will give me 5250. So it means my 15 cm is equal to 5450. So I'll divide both sides by 15 divided by 15. This means that the specific capacity of the metal is going to give me 363.3 joules per kilogram per Kelvin. So it means that at the end of the day, the specific capacity of this metal is going to give me 363.3 joules per kilogram per Kelvin. Moving on to the next question, which is question number 12. It says, a sealed container of volume 0.5 meters cubed. So we are given the volume as 0.5 meters cubed. Contains gas at a pressure of, so we are given the pressure of the gas as 2 times 10 raised to the power 5 Pascal. And then we are given the temperature as, and temperature 27 degrees Celsius. So if we convert that to be in Kelvin, this will give me 27 plus 273. That will give me 300 Kelvin. They say calculate the mass of the gas if the molar mass is 28. So we are given the molar mass as 28 grams per mole. Then we have to find the mass of the gas. They were given the constant R as 8.31 joules per mole Kelvin. Joules per mole Kelvin. So looking at this, we know that our formula for calculating this question is PV is equals to nRT, where our N is talking about our numbers of moles. And we know that our numbers of moles is always mass over molar mass. So if you impute that, that is the same thing as saying I have PV is equals to mass times RT over molar mass. So if you impute our values into this question, this is the same thing as saying that I have my Pascal here, or pressure is 2 times 10 raised to the power 5 times the volume is 0.5 is equal to the mass is unknown times 8.31 times the temperature was given as 300 Kelvin divided by the molar mass, which was 28. So this means that I have so that will give me 100,000 to be equal to 8.31 times 300, 2493 M divided by 28. So that will give me 28000. So I'll have 2.8 million to be equals to 2493 M. Divide both sides by 2493 divided by 2493. this means that the mass will give me 1123.14 grams. So it means that the mass of this particular gas is going to give me 1123.14 grams. On from there to the next question, which is question number 13. It says, a metal rod expands by 0.24 centimeters when heated. So a metal rod expands by 0.24 centimeters when heated. So we have the change in length here at 0.24 centimeters. It said when heated through 100 degrees Celsius. So our change in temperature is 100 degrees Celsius. Said if its original length is 80 centimeters, original length L0 or L1, you can say L0 or L1 is 80 centimeters. So calculate its linear expansivity. So we are looking for alpha. We do not know. But we know that alpha is equal to change in length all over L1 change in theta. So this is the same thing as saying that my alpha is equal to, my change in length here is 0.24. There's no need for you to convert your centimeters to meters because I have divided also by centimeters. So ordinarily, your centimeter is supposed to cancel out centimeters at the end of the day. Hence, your alpha does not have the unit of meters in it. So this is the same thing as saying I have 0.24 divided by 80 times my change in temperature here is 100. So this means that I have 0.24 divided by 8,000. So I have 0.24 divided by 8,000. That means that my alpha is equal to 3 times 10 raised to the power minus 5 per Kelvin. So it means that the linear expansivity of this particular metal rod at the end of the day is going to be what? 3 times 10 raised to the power minus 5 per Kelvin. Moving on to question number 14. It says, a 2 kilowatt heater. So they've given us the power of the heater there to be 2 kilowatts. So we have the power of this heater to be 2 kilowatts. So we have power as 2 kilowatts, which is the same as saying I have 2,000 watts. It's used to boil 1 kg of water. So we are given the mass of water as 1 kilogram. Initially at 20 degrees Celsius, it means my initial temperature, theta 1, is 20 degrees Celsius. How long will it take to convert it to steam completely? So we are looking for the time. We do not know. And we are converting it to steam completely, which means that the final temperature here is going to be 100 degrees Celsius. And they gave us the specific capacity of water as 4,200 joules per kilogram per Kelvin. And then they gave us the latent heat of steam, latent heat of vaporization of steam as 2.3 times 10 raised to the power 6 joules per kilogram. So we are looking for the time. So in this question here, they are converting water at a temperature of 20 degrees Celsius to steam, which means it will not only have latent heat of vaporization of steam, it will also have a specific heat capacity. It means that the work done by this heater, which is power times the time, is equals to your MC change in theta plus ML. So the amount of heat that is given off from the steam, or in converting it from boiling water to steam, plus the amount of heat that is used in heating it from 20 degrees Celsius down to 100 degrees Celsius will give me the total amount of heat that was supplied by the heater. So this is the heat lost here. So the heater is the one losing heat down to the water that you are heating up to 100 degrees Celsius until it is completely converted to steam. So this means that what I'll be having here is 2,000 times T is equals to the mass that was used was 1 times 4,200 times my change in temperature here is going to be 100 minus 20 plus The mass that was used for converting it to steam is T1 times the specific latent heat, which is 2.3 times 10 raised to power 6. So this means that I'll be having 2000 T is equal to 4200 times 80 plus 2.3 times 10 raised to power 6. So this will give me 2000 T to be equals to 4200 times 80. So this will give me 336,000 plus 23,000,000. So if I add those two together, so this will give me 2000 T to be equals to 26,36,000. So I'll divide both sides by 2000, divided by 2000. It means that my time is going to be 1318 seconds. So it means that the time in seconds is going to be 1318. So if I want to convert it to minutes, I can just divide by 60, and that will give me, that's equivalent to saying I have 21.96 minutes. So in seconds, what you're going to be getting at the end of the day is going to give me 1318 seconds. Moving on from there to question number 15. It says a body at 600 Kelvin. So we have the first temperature here, T1 at 600 Kelvin. Radiates energy at a rate of 120 watts per meter square. So we have the energy as 120, let's say this is E1, 120 watts per meter square. Calculate the rate at which it radiates energy. So we are looking for a new energy, E2, unknown, when heated to 1200 Kelvin. So we have T2 as 1200 Kelvin. So if you do a ratio comparison here, it means what you're just going to do is tell them that your E2 over E1 is going to give me T2 over T1 all raised to power 4 according to Stefan Boltzmann equation. So if you apply Stefan Boltzmann equation in this, it means what I'm going to be having simply is going to be my E2 will be equals to E1 times T2 over T1 raised to power 4. So this is the same as saying that I have my E2 to be equals to E1 is 120 times, this will give me 1200 divided by 600 all raised to power 4. So this will give me 120 times, this will cancel this and I'll have, this will give me 2 raised to power 4. So that's the same as saying I have 120 times 16. So I have 120 times 16. So this will give me 1920 watts per meter square. So it means the rate at which it radiates when it is heated to 1200 Kelvin is going to be 1920 watts per meter square. So we've come to the end of today's class. I believe you enjoyed this class. Don't forget to go to our channel for more videos just like this.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams, including JAMB, WAEC, Kakao,